Hi Year 12s, hope you're doing okay. Just looking at sort of the early student feedback or survey on lessons, one of the things that's come through that's been really positive have been sort of videos of lessons and sort of voice recording. So what I'm going to sort of do is do one for my physiology, one for this week, but also going through some of the stuff that we looked at last week. Right, so the first thing to sort of recap from last week's lesson is this bit here, Obla. Now, Obla stands for the onset of blood lactate accumulation. It is also the same as the lactate threshold. So I know that the lactate threshold was the topic, title of last week's lesson. Lactate threshold and Obla are essentially the same thing. Okay. And this figure here at the left was something that you took down in your notes, okay? One of the other things to sort of remind ourselves about, and it's a key knowledge point that sort of links the James Morris video that you looked at last week, but also looking at the content of this week's lesson that I'll be going through shortly, is the relationship between VO2 max and Obla. Okay, and this figure shows it really, really clearly. One key sentence that I would really take a note of as you watch this video is the following, is that Obla is a percentage of your VO2 max, okay? Obla is a percentage of your VO2 max. So you can see here with the untrained and trained individual that the untrained individual has a lower VO2 max, and therefore their Obla, the point at which lactate starts to accumulate in the blood, occurs much earlier. Okay, and you can see here that it's a much higher percentage of VO2 max. So Obla is a percentage of VO2 max. So the higher your VO2 max as an athlete, the greater the delay in your Obla, and therefore you'll be able to work aerobically for longer. And that is why endurance athletes, people like Sir Mo Farah, for example, have a high or higher VO2 max. They're able to work aerobically for longer. Right, what this question's looking at is factors that can affect the rate of lactate accumulation. It's not looking at about what I've just talked about Obla being a percentage of VO2 max. What this is actually looking at are factors that can affect the rate of lactate accumulation, and this was one of the content. This was part of the content of last week's lesson. Okay, I would sort of pause the video at this point if I was doing this if you were doing this as a lesson, and I would actually attempt an answer to this question. So if you were to pause the video now, and then when you play the video back, I'll be going through the mark scheme with you. So, there's essentially two sections to this mark scheme. If we focus on points A to C to start with, okay, if we were looking at an extended response, A, B and C would be AO1, would be knowledge marks, but for the basis of this question, you would actually get credit for this. So you can see A is a good definition of what Obla is. And the other good thing about Obla, the definition is in the key term. Onset, blood, lactate, accumulation. Okay, and notice that the word blood is underlined, so you'd have to make sure that you refer to it in the blood. Okay. Notice as well that this was mentioned in the PowerPoint last week, that when does Obla generally take place? And it generally occurs at 4 millimoles per litre. Now, next week's lesson will look at how you actually measure for blood lactate in the process of what we call lactate sampling. Okay, and point C is an explanation of why Obla, the lactate threshold, takes place, and essentially it's your ability to work aerobically is compromised because you're not getting enough oxygen into your muscles. Okay, so that's the first sort of 3 points. That would be knowledge for an extended response. Okay, the actual factors that can affect the rate of lactate accumulation are those bits there I've just highlighted in blue. The key things to answer about this question is you wouldn't just say the factor. And this is something that's come up in previous years when I've taught this. A lot of students can remember the factors that can affect the rate of lactate accumulation, but then they don't actually go on and say how the factor affects it. Now, if I just use the intensity of exercise as an example, there's 2 ways you can go with answering a question like this. Okay. One way you can structure your answer is how is each factor going to speed up Obla? And what do we mean by that? If Obla is being sped up, it's going to occur much more quickly, and therefore you're going to be working anaerobically much more quickly. The other way you can structure your answer is how will each factor delay Obla. And obviously if Obla is being delayed, less lactic acid is going to be produced, and therefore you're going to be working aerobically for longer. Now, you don't have to talk about both aspects and whether speeding up Obla or delaying Obla for each factor. As long as you address one or the other in your answer, it does not matter. Okay, and you can see that points D to H sort of do that. Okay, so you can see with D, the intensity of the exercise, that point there is looking at how Obla will be sped up. So if I just change, back to my blue. So you can see there, faster Obla. So if the intensity of the exercise is higher, that will speed up Obla. And vice versa, you could say that the lower the intensity of exercise, that would delay Obla. Fitness of the performer. Now, fitness of the performer here will link to a mind map that you're going to be producing within this lesson, but also a lot of the content of the James Morris video from last week will be relevant here. Now, I'm just going to highlight, if I go back to my red to sort of stick with the delay, more mitochondria. Now, more mitochondria is a physiological adaptation if an athlete is doing a lot of aerobic-based training. So therefore, if an athlete has more mitochondria in their muscles, that will delay Obla. And vice versa, you might say that if an athlete is doing a lot of anaerobic training, they may have fewer mitochondria, and that would therefore speed up Obla. You'll also see there about VO2 max of the athlete. So obviously the higher the VO2 max, that will delay Obla, and obviously vice versa, you could say that the lower the athlete's VO2 max, that would speed up Obla. The respiratory exchange ratio, I'll actually go through that in more depth next week. That is actually a measurement of energy expenditure on the specification. But ultimately, at this stage, all I would worry about just at this stage is that the closer your RER value is to 1, and that's the highest it can be, your RER value generally ranges from 0 to 1. And it ultimately is determined by which predominant energy source is providing the energy, but that will come in more detail next week. And then the final factor, so there's 5 in total for you to know, and it comes back to the neuromuscular system that we looked at earlier in the year. It comes back to muscle fibre type. So if you predominantly have a higher percentage of slow twitch muscle fibres, one thing you might want to test yourself now is, do you remember the scientific name of slow twitch? And the answer is slow oxidative. So if an athlete had a high percentage of slow oxidative fibres, that would delay Obla. Okay, so that is going through the mark scheme for that particular question. Hopefully that might address any sort of problems, misconceptions with the lactate threshold from last week's lesson.